In this video, we are looking at e, y equals e to the power of x. E is a number. So if we press shift and then this LM button, we bring up e. If I put a 1 in there, e to the power of 1 is 2.718 and so on. So e is just a number. It's equal to 2.718, and that's an irrational number. It's a number that goes on forever. The reason e is a special number is because the function and the gradient function are exactly the same. So where we have a graph of y equals e to the power of x, it crosses at 1. At this point, where we have, let's move it over a little bit. So at this point, when x is 1, the y coordinate is 2.718, and the gradient is also 2.718. Where we have e squared, we get 7.34 and so on. So at the point when x is 2, the gradient and the y coordinate are both 7.34. So the gradient and the function, the y coordinate, are always the same. Use your calculator to work out the value of e cubed to 5 decimal places. So we just press e cubed. So to 5 decimal places, we've got 20.08554. So 20.08554. Use your calculators to work out the value of e squared to 5 decimal places. Give it a go. And we should get 7.38906. 7.38906. Sketch the graph of y equals e to the power of x. So again, it's just an exponential function. It crosses the y-axis at 1. It never reaches the x-axis. So that is all we have to do to sketch the graph. See if you can have a go at sketching the graph of y equals e to the power of negative x. So what's the transformation that's happened? The x's have become negative x's. That's the same as f of minus x. So our positive x's become negative. Our negative x's become positive. So our graph looks something like this. A reflection, a flip over the y-axis. Sketch the graph of y equals 3e to the power of 2x. So what has happened this time? So the 3, so it's the same as 3f of 2x. That's our transformation. So we're multiplying all of the y coordinates by 3. So where it crossed at 1 before, it's now going to cross at 3. And the 2x is going to squash the graph in. So we're going to have a graph that looks like this. One for you to try. See if you can give it a go. So this time we're multiplying the y coordinates by 4 and adding 1 to the y coordinates. So it's the same as 4f of x plus 1. So the whole graph is shifted up 1 and multiplied by 4, or multiplied by 4 first, and then shifted up 1. So where we're at 1, times it by 4, plus 1, that becomes 5. The whole graph is shifted up 1. So there's now this asymptote at y equals 1. So where before, it never touched the x-axis, now it never touches the line y equals 1. And the graph has the same shape as it did before. Sketch the graph of 5 minus ex. So this would be minus f of x and then plus 5. So we are flipping it over. All the positive y's become negative. So y equals minus ex would be like this, but we're also moving it up 5 spaces. So instead of -1, it's going to cross 5 spaces up at 4. The asymptote would have been at 0. Now going to be 5 spaces up at 5. So our graph is going to look like this. Usually when we sketch a graph, we want to know where it crosses the x-axis and the y-axis. This one crosses the x-axis as well. We haven't learned how to work out that coordinate yet, so we'll leave it like that. Sketch the graph of y equals 10e to the power of -x. See if you can give it a go. So it's the same as 10f of -x. So the negative x inside the bracket means all the positive x's become negative and all the negative x's become positive. So that changes the direction. And where it crossed the y-axis, it was at 1. It's now been multiplied by 10. So now it's crossing at 10. Now we're going to look at differentiating. So as I said before, the reason that e is a special number is because its gradient function is exactly the same as the function. So e to the power of x differentiated is e to the power of x. E to the power of 2x. When you have a 2 in the power, we leave it as it is, so e to the power of 2x, but then we multiply the whole function by 2. So the gradient function is 2e 2x. So we multiply it by the number. So e2x, if it was e3x, it'd be 3e3x. If it was e5x, it'd be 5e5x. So the gradient function is 2e 2x. And this last one, we have to expand the bracket first before we can differentiate. E to the power of x times e to the power of x. We multiply indices, we add the powers. That's e to the power of 2x. And then we've got 2ex. So that's what we're differentiating. So our gradient function, e to the power of 2x differentiated is 2e 2x timesing by this constant. And 2ex differentiated is 2ex. Here are some for you to try. Give it a go. So differentiate with respect to x. 5ex differentiated is 5ex. 2e4x. So it stays the same, but we times by the constant in the power, times it by 4. So the gradient function is 8e4x. And then the last one, e3x differentiated, is 3e3x and 4e negative x. So there's a constant of -1 in the power this time. So we're going to times it by -1. It's going to be -4e to the power of -x. Find the gradient of the graph. Y equals 3e2x at the point where x equals 2. So let's find dy dx. So whenever we need to find the gradient, we're finding dy dx, the gradient function. Differentiating this so it stays the same, but we times by the constant in the power, which is 2. So it is 6e2x. When x is 2, dy dx is 6e to the power of 2 2's, which is 4. That would be fine as an answer. That's an exact answer. If we did need to give it as a decimal, we could just type that in the calculator. 6e to the power of 4, and we get 327.6. But I'm going to leave it as the exact answer. One for you to try. Give it a go. So dy dx, so it stays the same, but you times by the constant in the power, which is 2. So it's 2e2x. And when x is equal to 3, our gradient is 2e to the power of 2 3's, which is 2e to the power of 6.